Good day. In today's video, we will be discussing about traffic impact assessment. This slide here shows the outline of what I'm about to discuss. But before we go on further, let us deal first the definition of traffic impact assessment. So when we say traffic, it comprises pedestrians, vehicles, and other conveyances that use public ways or roads for travel and transportation. When we say impact, it's having a strong effect on someone or something. And assessment, it's the evaluation of the quality or ability of someone or something. So in short, traffic impact assessment is the evaluation of the effects of traffic. So traffic impact assessment is a useful method for evaluating potential impacts of traffic generated by proposed development to the surrounding transportation system. TIA typically includes a description of the proposed project scope and intensity, an overview of the projected impacts, and any required improvements to ensure that the roadway facilities can safely accommodate the proposed development. So the goal of the TIA is to ensure that the transportation system will operate safely and efficiently within the design horizon of the study. So a well-prepared TIA helps the developer and permitting agency accomplish update traffic data, relate land use decisions to traffic conditions, utilize money allocation more effectively, estimate the traffic impacts of a proposed development by creating reasonable future traffic volumes for design purposes, assess whether modifications are required to accommodate background traffic as well as traffic from a projected development, and lastly, provide a basis for determining the developer's responsibility for specific off-site improvements. So a well-prepared TIA serves as a comprehensive tool for assessing and addressing the potential traffic implications of a development, promoting safety, compliance, and efficient use of transportation infrastructure. So the main objective of traffic impact assessment is to determine whether a certain development project will have an effect on the efficiency and safety of adjacent roads. It lays the path for further investigation and development of traffic management plans that help minimize traffic congestion. So the TIA considers not only traffic impacts such as road network efficiency and safety, but also the impacts on all road users, including public transport users like pedestrians and cyclists. The TIA considers both impact on operations and physical impacts on transport infrastructure. So any development needs to have adequate infrastructure to support it, whether utilities or transportation. As a result, every proposed development requires an assessment of the adequacy of the site and any necessary improvements to safely accommodate the proposed development. In general, there are two levels of assessment that may be required in support of a development. The comprehensive report, which is used for larger development with significant traffic impacts or at complex location where the recommended improvements require a detailed analysis, and the memo report, which may be used for small development with low traffic impacts at simple location where the recommended improvements can be assessed in a memo format. Typically, a subdivision, pre-development plan, or development that potentially generates high traffic volume requires a comprehensive TIA, while if the anticipated traffic impact is low, a memo report may be sufficient. So before a developer can make adjustments to a municipality's land use, subdivision, site, or driveway plan, a TIA must be submitted. If TIA is not required, it is at the discretion of the city or municipal planning development office to mandate a traffic operation study to address local transportation issues. To obtain specific TIA requirements, developers must engage with the relevant agencies, which include the Department of Public Works and Highways, the Department of Transportation and Communication, the Metro Manila Development Authority, and the local government unit. As the TIA is often conceptual in nature and relies on many assumptions, its assumptions may need to be verified from time to time when new or additional information becomes available. The acceptance of a TIA should not be viewed as final, as subsequent updates to the TIA may be required. Since the TIA is a technical document that other studies and approvals rely on, it needs to be as accurate as possible. A TIA outlines engineering judgments and recommendations. Therefore, a TIA must be signed off by a qualified professional transportation engineer. An unsigned TIA is not acceptable and will not be reviewed. So, traffic impact assessment involves a systematic process to evaluate the potential impact of a proposed development on the existing transportation infrastructure and traffic conditions. It involves site visit and base data collection like traffic counts, pedestrian counts, road measurements, site distances, traffic speeds, sidewalks, and street lighting. It defines the study area and road network within the study area, assess the existing traffic and road safety conditions on the road network in the study area, review the development or change in road network that will result in change in traffic flows, estimate the volume of traffic that the new development will generate and distribute this traffic onto the surrounding road network, add the additional traffic to existing traffic and assess the impact, assess the impact of this additional traffic on the road network within the study area, calculate the forecast traffic volume, add the additional traffic to the forecast traffic and assess the impact, establish the mitigation measures required to address the impact of the additional traffic for existing and forecast traffic conditions. So it's essential to note that the requirements for a TIA can vary based on local regulations and the nature of the proposed development. Consulting with local planning authorities and transportation agencies is crucial to ensure compliance with specific guidelines and requirements in a given jurisdiction. Land use is under municipal jurisdiction. Therefore, all TIA correspondence should involve the municipality. This ensures that any decisions or changes related to land use can be properly addressed and regulated by the local governing body. It also helps maintain consistency and accountability in managing land development projects within the municipality. So it is essential that the developer's proposal be compliant with both municipal and highway plans. As municipality plans and highway plans may be developed independently of one another and revised from time to time, it is the developer's responsibility to gather all the relevant and current information in order to make an informed decision on whether to invest their time and money into a project. So it is advised that before starting any TIA work, the required scope, acceptability of the access locations, assumptions, methodology, expectations, and requirements be determined in order to prevent doing any needless work. A scoping meeting with the municipality would be helpful to discuss about the proposed development plan to determine whether a TIA is required or not and the scope of the study for the upcoming TIA. The developer and its consultant should discuss whether the municipality is willing to consider changing the usage of an existing access or creating a new one. So, as a TIA is often based on many assumptions, to achieve an acceptable TIA while minimizing the number of revisions, all such assumptions should be agreed to by the reviewing parties before conducting the TIA. The reviewer may have a certain preference or limitation in regard to analysis tools that should be confirmed as well. So the report should be concise, organized in a step-by-step approach, and easy to verify and comprehend. Any assumptions must be justified and backed up by sufficient evidence. The suggested study format will help ensuring consistency among various studies and help enhancing the efficiency of the report review process. So the format includes an executive summary, introduction and proposed development information, future highway and municipal plans, existing infrastructure conditions, background traffic and projection, development traffic, post-development traffic, intersection treatment warrants, analysis, conclusions, and recommendations, including the proposed intersection plans, appendices, scoping and supporting documents, calculations, correspondence, etc. So the report content will be discussed further by my groupmates.
Good day everyone, I am Riza S. Paalisbo and I am assigned to share with you the executive summary of TIA, which means the Traffic Impact Assessment. So the TIA prepared shall include an executive summary at the beginning of the TIA report to provide a short synopsis of the key findings, conclusions, and recommendations. So at a minimum, it shall contain the following information. First is the location of the study site with respect to the area roadway network. Second is the description of the proposed, including types, sizes, land uses, construction facing, proposed accesses. So the proposed development means the construction and the property of buildings for use as dwellings comprising not less than square feet as may be amended by planning applications approved by the landlord. So third is the discussion of the principal findings of the analysis, including existing traffic conditions, program transportation improvements, amount of site-generated traffic, projected traffic volumes. So, the fourth one is the summary of the study conclusions, including future levels of service with and without proposed development. Then, identification of all mitigation measures recommended, including a discussion of when to implement or improvements to achieve the best loss on highway network. So when we say loss means level of service that are widely used in transport planning to evaluate problems and potential solutions. It is also influence transport planning decisions. So next is the introduction and proposed development information. The introduction of background information is to provide understanding of the proposed development and its location with respect to the provincial highway system. This portion of the report should provide the following information. A is the history related to the transportation analysis. So, transportation analysis provides the basis for transportation planning. B is the overview of the scope of the study. So, Work Traffic Impacts Assessment, or the TIA, is a study that evaluates the effects of a proposed development or land use charge in the surrounding transportation network. Letter C, proposed development. So in this part, there are two subcategories of proposed development. First is the on-site development and the second is the study area. So under the on-site development is the name, location with legal land description of the proposed development. So the legal description identifies the property's geographic location and boundaries as determined by a surveyor. So it is also ensures that the correct property deed is transferred to the new owner and that the correct property ownership is recorded on the new deed. While in the study area, so we have the influence area, typically within 1 kilometer from the first highway access. Second is the area of significant traffic impact. And the third one is the adjacent land uses and other developments nearby. Letter D is the existing road network. So the highway number or the cross section and kilometer. Second is the highway service classification. So, we have a sample picture here for the proposed classification relationship by Alberta Highway System. So, in the service, level 1 is the National Highway System, level 2 is the arterials, level 3 is the collectors, and the level 4 is the locals. So, under the level 1, in the roadside management, it has a freeway and a multi-lane highway. While in the level 2 arterials, it is include the roadside management, the freeway, the multi-lane highway, and the major highway. While in the level 3, it is only include a minor highway in the roadside management. And same as level 4, the locals. So for the design of the roadside management, the freeway is also under a freeway, under multi-lane, and the two-lane. So for the roadside management multi-lane highway, it is under in the design multi-lane and the two-lane, while the major highway is only under two-lane, the same as the minor highway of the roadside management. So as you can see in the picture, we have a sample of a roadside management classification map. So So here, so for letter E, maps and plans, we have two plans, the site location plan and the site plan. So we have an example picture here. So as you can see the difference between the location plan and the site plan. So a location plan must be based on up-to-date map and at a recognized standard metric scale, and must illustrate the plan development in relation to its adjacent properties. So this is the sample picture. So here the first picture is the example of the location plan. Second is the site plan. So, the site plan, also known as block plans or plot plans, shows the intended development location in respect to the property boundaries. They are most often submitted in either a 1:200 or 1:500 scale. So here is the sample picture. So these two. Site plan at 1:500 scale. For the access management, highway and municipal. So access management is the planning, design, and implementation of the land use and transportation strategies that controls the flow of traffic between the road and surrounding land. A TIA is not only an operations assessment, but also a planning exercise. All development need to be compatible with the municipality and highways plans. So understanding the existing and future plans within the study area is essential to evaluating the impacts of the development site. So the TIA report should provide the reviewer a full understanding to the study area. It should discuss whether the proposed development is compatible with such municipal and highway plans and recognize the potential conflicts, impact, and opportunities, or incorporating improvements to address the impact as required. So, in the existing infrastructure condition, the purpose of this section is to present the existing roadway system in the area servicing the proposed development. So, the report should provide a description of the existing transportation system and its condition within the study area, emphasizing the major travel routes to and from the site. So it is recommended that a site visit or inspection be conducted as part of any TIA. Existing highway and road conditions. So we have the existing lane configurations. Then let me show you the picture. So here, the first picture. So as you can see there were signs for the existing lane configuration. Design and posted speed limit of the highway and the intersecting roadway. Then, the location of speed limit changes. So here, we have the type of road, then the maximum allowable speed for passenger cars and motorcycles, the maximum allowable speed for motor trucks and buses. So when it comes to expressways or open country roads, so 80 km per hour, the maximum allowable speed for passenger cars and motorcycle, while 50 km per hour for the maximum allowable speed for motor trucks and buses. So when it comes in the boulevards, the maximum allowable speed for passenger cars and motorcycles is only 40 km per hour, while the maximum allowable speed for motor trucks and buses is 30 km per hour. So when it comes to the city and municipal streets, so 30 km per hour for the maximum allowable speed for passenger cars and motorcycles, and 30 km per hour for the maximum allowable speed for motor trucks and buses. So for the locations of speed limit changes, the speed limit zone area becomes effective at the point you reach the sign. So if the speed limit sign or zone changes to a slower speed, slow down before the sign and not after. So, if the speed limit changes to a higher speed, wait until you get the increased speed limit sign before increasing your speed. Next is the pavement width and lane marking. So, we have pictures here. So, as you can see, there are two pictures. The one is for the pavement width and the one is for the lane markings. So, as you can see, you can see the pavement width at the middle of the carriage width and the sill width, and both sides is the shoulder. So here for the lane markings, for the broken yellow, double solid yellow, broken white, double solid white, and the dotted white. So a solid yellow line indicates that passing is prohibited. A dashed yellow line indicates that passing is allowed, while the white lines separate the lanes for which travel is in the same direction, and a double white line indicates that lane changes are prohibited. A single white line indicates that the lane changes are discouraged. Next is the right-of-way width. So, as you can see in the picture, we have 33-foot right-of-way. So, the width of the right-of-way in the Philippines, according to the National Road, shall have a right-of-way not less than 20 meters, provided that such minimum width may be reduced at the discretion of the Minister of Public Highways to 15 meters in highly urbanized areas, and that a right-of-way of that least 60 meters shall be reserved for roads. So, the next one is the horizontal and vertical alignment of highway. As you can see in the picture, we have the horizontal alignment in front view and the vertical alignment in profile view. So the horizontal alignment of a roadway is defined in terms of straight line tangents and horizontal curves. So the curves allows for a smooth transition between the tangent sections. Circular curves and spiral are two types of horizontal curves utilized to meet the various design criteria. And for the vertical alignment of the highway, generally defined as the presence of height and depth in vertical axis with respect to horizontal axis of alignment. So these heights and depths in roads may be in the form of gradients, or the straight lines in a vertical plane, or vertical curves. Then, for the vertical grades of the highway. The vertical profile grade is the percent of elevation change along the center line of the roadway. So, vertical grades are necessary to assure drainage of storm water within the plaza to inlets and or outfall locations. So, vertical curves, also known as grade curves or sag curves, are gradual changes in the slope of a roadway or railroad track along the vertical axis. So they are used to transition between different grades or slopes smoothly and safely. So for the sight distance, this is already very familiar to us since our teacher is already discussed this one. Stopping sight distance is one of several types of sight distance used in road design. So, it is a near worst case distance a vehicle driver needs to be able to see in order to have room to stop before colliding. Colliding with something in the roadway, such as a pedestrian in a crosswalk, a stopped vehicle, or the road debris. This is the longitudinal barrier and the end treatments. So here, as you can see in the picture, there is the end treatments. So the end treatments are a critical component of any barrier system whose primary function is to increase the safety of occupants of an errant vehicle impacting a barrier or roadside hazard by absorbing the kinetic energy of an impact. So next is the hazard in the clear zone. So when located within the clear zone, these continuous hazards are roadside hazards. So the length of the hazard increases the likelihood an errant vehicle will strike it. And some hazards have a high crash severity regardless of the speed of the errant vehicle. So a clear zone is an obstructed, traversable roadside area that allows a driver to stop safely or regain control of a vehicle that has left by roadway. So next is the existing illumination in Vinicity. So let me show you a picture. So here, it's like a street lights. So it is the area illuminated by lighting in certain areas of the site plan. Then the traffic control type. So here is the picture. As you can see, there were lots of signs for the traffic control type. First is the signs. So we've all seen road signs. It is how we get information as drivers, pedestrians, and general road users. So signs are used to indicate changes in the speed restriction. Traffic signals. So traffic signals are used by properties to guide traffic in additional to signage. Typically, traffic signals should be able to capture attention, offer context, and provide time for responses, as well as limit wasted time. The road markings. So the road itself is used as a different kind of traffic safety device. So on the pavement, curb, sides of islands, or on nearby permanent objects, there are road markings in the form of lines, patterns, words, reflectors, or symbols. For the traffic operation signage, you can see those things on the figure when it comes on the traffic operation signage. So the red generally means the use of red on signs is limited to stop, yield, and prohibition signs. So a white background indicates a regulatory sign, while the yellow background conveys a general caution message. While with the green shows permitted traffic movements or directional guidance. Existing and planned accesses in vicinity. So example for that are the driveways, frontage roads, and the private roads. Next is the any other modes of transportation. So example of that are the railway, pedestrians crossing, trail, the bicycle lanes, transit roads, and stop. And the last thing is the any existing operational issues and apparent collection issues. So that's all for my report. Thank you.
The traffic condition. The background of the traffic. This section determines the background traffic volumes that will be used in analysis of the proposed development. The report should be contain information on existing 24 hours traffic volumes and should be also provide existing peak hour turning movements volume for the major intersection in the study area. The peak hour shall be determined as any time frame that will have the greatest impact to the highway system, and this will generate the highest volume of traffic from the development that day. So the existing background traffic, the objective this traffic count is to capture the true demand. We need to always monitor the traffic condition since in every intersection there are always a possibility a traffic. Kay mostly manggod ang nakakos sa pag-traffic sa ato ang syudad, sa atong place is the intersection area. So of all turning movements for all vehicle classification, so any congestion and queuing should be estimated and recorded. When measured in the field, traffic count taken upstream in the queue associated with the subject intersection. So the traffic condition during the signal warrant worksheet. So we need to we need to we need to factor the method listed. So the scenario 1, the traffic count was collected in a day. So ADT in the count year, ATR over ATR 24 hours daily volume on the count day. So pag factor nimo siya for the current year zone, so equals to year traffic count times factor times 1 plus growth rate percent times number of years. So sa usahay po sa atong pag monitor sa traffic, so napatay scenario 2, the traffic count is collected in the current year where ATR 24-hour count in the AADT for the current year are not available. So factor equals to AADT in last year over ATR 24 hours daily volume in the count date in last year. So when the pedestrian demand is present at a study intersection or where pedestrian traffic accommodation is anticipated, pedestrians should also collected. So we need to so if the traffic when the traffic costs too much, so we need to have projected background traffic. The long-term traffic growth follows for more linear growth pattern as opposed to exponential or compound growth. As a result, traffic growth rate is calculated as a non-compounded average annual growth rate expressed as a percentage of the count. Traffic volume count, the consultant should be estimated traffic growth rate from the historical traffic count data from the projection models. The consultant should make the choice method with the goal of selecting reasonable growth rate has a low probability of understanding the future traffic volumes. So, sa primero pa lang, no, pagkakita na to sa traffic, so we need to create a solution to project how to avoid the traffic growth. So, in this scenario, we need to choose what is the most applicable of that area causing of the traffic volumes. Then, we need to propose. So, the growth projects are performed using formula. So, the formula is TV future equals to TV existing. 1 plus the number of years times percent over 100. So, as a when the traffic growth rate is dynamic, different growth rates may be used for different developments horizon in order to simulate the traffic growth trend. However, justification must be provided. Although the traffic growth rates varies for every section of highways, the average annual compounding growth rate on the provincial highway network is about 1.5 to 2.0% from year to year. If there are not sufficient traffic count data to determine the traffic growth rate, historical traffic indicates negative or low growth for the purpose of TEA, the Traffic Impact Assessment. An average annual non-compounded growth rate is 2%, should be lower than provincial highways. So, gamay ra ang porsyento no nga magka-cause of traffic sa probinsya, di ba? Lalo na katong naka-experience diha og nata sa probinsya no, dili kay siya traffic. So, gingon siya diri nga ang average non compounded sa mga provincial is 2% ra ang growth rate. So, dili jud kay siya taas ang cause sa traffic sa mga probinsya. Unlike the cities no, kay diha jud na to masinati ang pinaka-traffic. So, the traffic impact assessment siya dapat siyang maghimo og plano, solution para maiwasan ni ani. The traffic projection must be prepared for the build year or such other years as may appropriate due to development staging. So the background of traffic should be projected to minimum 20-year horizon at this represent the average life most pavement structure. So kung ano, mostly no sa ko sa tong traffic no, kita-kita ra man jud pod ang makakos kasi depende man po sa driver labi nag pataka ra bitaw siya og liko so makakos siya og traffic sa atuwa. Labi na mo kalitrag na mo tabok sa intersection dayon mahunong tong kalitong nasa imong unahan. Then sa likod nagsunod nimo makahunong ka siya kalitpod. Then the rest na magsunod-sunod nito mahunong pati makakos og traffic sa ato ang highways. So this traffic should be avoided no. Kaya man nato siya malikayan basta natay saktong plano himuon. So we need to establish the highway to minimize, at least minimize man lang no, ma-minimize ato ang traffic sa ato ang mga kalsada, especially the highways, the cities. So the traffic generated by other developments. Traffic projection generated by other nearby proposed plan. Development should be taken into account. The proponent should be contact municipality for the future and land information. When multiple developments are advancing developments proposal that affect the study area, and a joint TEA should be coordinated with the review cumulative impact. So sa traffic condition, napunta combined traffic. The combined traffic, once the development traffic has been identify the projected background traffic, other development traffic, and site generated traffic should be combined for the determined peak periods. The combined should be projected at least 10 year to 20 years horizon. And the commencement day of each development stage, this information should be supplied in graphical tabular.
Intersection treatment warrants. Intersection treatment warrants should follow the current trans highway geometric design guide, HGDG, and any related design bulletins. The intersection treatment warrant system has been prepared to assist designers in choosing the appropriate intersection treatment based on the main and intersecting road volumes. In order to determine the appropriate turning base storage lengths, percentage of heavy vehicle traffic, volume should be calculated. T is defined as the total number of tractor-trailer combinations and single unit truck plus half of the recreational vehicle and half of the buses. Next is intersection treatment for over-dimensional vehicle. When over-dimensional load are involved, designers should take into consideration some of the guidelines in Design Bulletin 68 where intersection adjustments such as semi-mountable curbs, location, offsetting of roads, appurtenances, clearance, height, etc. may be required. Next is capacity analysis. Capacity analysis must be undertaken for all traffic scenarios as appropriate, such as signalized and unsignalized intersection, roundabouts, weaving, merging, diverging, queuing analysis, intersection traffic controls, etc. as per the Transportation Research Board Highway Capacity Manual or HCM. Both intersection treatment warrant and capacity analysis for existing conditions and future conditions need to be performed and satisfied. In cases where the proposed development utilities an existing intersection, it is necessary to first understand how the existing highway and or intersection would operate without the development. The TIA should include intersection treatment warrant and capacity analysis for the existing intersection for the commencement day, 10-year and 20-year horizon without development traffic. Impact should also be evaluated with the combination traffic background plus development for the commencement day, 10-year and 20-year horizon for each stage as the next stages may not go ahead. When improvements are required at certain horizon years, it is required that the TIA consultant determines the year that the improvements are triggered. This can be achieved through interpolation. The TIA report should summarize capacity analysis result with but not limited to the following information for each analysis scenario. First, level of service or loss by turning movement for each intersection. Second, V over C ratio. 3. Delay per movement, seconds, and last is Qui length and meters. All intersection capacity analysis outputs, including but not limited to synchro file, traffic signal, warrant sheet, left turn and right turn warrant sheet, should be included in the appendix of the TIA report. Consider analysis of pedestrian, bicycle, and transit facilities when such services are present or planned for the area, especially if the proposed development will generate bicycle, pedestrian, or transit trips. Next is traffic control needs. The TIA preparer should consult with Trans when considering traffic control and intersection type. Trans utilizes TAC's traffic signal and pedestrian signal head warrant handbook when determining the warrant of signalized intersections. Trans follow the 100-point system where collision risk is inherently considered with the Canadian traffic signal warrant matrix procedure. In the traffic signal warrant sheet, the peak hour traffic count table should be filled with the highest 6-hour factor to a type of day traffic count, 3 hours in the morning and 3 hours in the afternoon. The hours do not need to be consecutive. Analysis should be conducted to ensure that the current signal timings and phases are appropriate. In situations where adjacent roadway involves a corridor or 2 or more signalized intersections, are closely spaced, traffic signals coordination and corridor analysis are required. All warrant calculations and analysis worksheets should be included in the appendix of the TIA.
So now let's proceed to traffic safety. Traffic safety is safety of all road users must be taken into consideration during the preparation of the TIA. The report should identify and make recommendations regarding any geometric and operational issues that may impact safety, as well as any apparent collision issues. So for example, when there is significant concern for the development effects on road safety, a more detailed traffic safety analysis is required. So next is design vehicle accommodation. An assessment of design vehicle requirements is a critical phase of the TIA and must not be overlooked. As a part of the intersection improvement analysis, it is necessary to ensure that the design vehicle is capable of safely maneuvering the intersection without interfering with other traffic movements. So, an intersection and design vehicle's turning plans should be provided to demonstrate that the design vehicle for the existing and proposed development using the intersection can safely maneuver through the intersection and on the development site with appropriate turning room. The design must also accommodate the storage for left turns off main road or while waiting on the intersecting road, and reviewed requirements particularly for the space between the lanes on a divided highway. The access management and rights of way. It states that the TIA report must address improvements to the highway involving removal, relocation, or alternation of existing accesses to maintain minimum spacing and ensure highway safety under post-development conditions. So, if the location of existing or proposed intersection is a concern, for example, insufficient intersection site, distances, intersection on grade or curve, insufficient access spacing, proximity to adjacent intersections, and accesses. The TIA consultant should evaluate access or corridor operations analysis, for example, waiving analysis, and provide options such as alternate access, consolidations, or relocation of their proposed access, and discuss with the transportation prior to the further analysis. A planning level intersection layout indicating the required right-of-way for the proposed development access is required. For other considerations may include impacts on noise and other modes of transportation, traffic noise assessment, and mitigation by the development may be required. So, any proposed improvement that does not meet transportation standard should refer to transportation design exception guidelines. It is the TIA consultant responsibilities to clearly document any items that deviate from the current transportation standards and provide rationale for the recommended mitigation strategies. So that's all. Thank you for listening.